Today we're going to be looking at CVE-2026-41179, which is a unauthenticated remote code execution in Rclone. We're going to cover what Rclone is, a high-level exploit chain for this vulnerability, a lab demo, and also a remediation for this vulnerability. What is Rclone? Well, Rclone is a widely used open source tool for syncing files to cloud storage, S3, Dropbox, Google Drive, and dozens more. It also ships with a built-in remote control API called the RC interface, which lets you manage Rclone over HTTP. That RC interface is the source of this vulnerability. So the first step is that the attacker sends a post request to operations/fsinfo. This is an endpoint that is a legitimate part of the RC API. Its job is to return metadata about the file system, things like supported features and hash types. It accepts a single parameter called fs, which tells Rclone which backend to inspect. There is no authentication check on this endpoint. Any unauthenticated HTTP requests reaching the RC port is accepted and processed. This is the first design flaw. The endpoint was simply never marked as requiring authentication in the codebase. Step 2. In Rclone's RC framework, each endpoint can be registered with an authentication required :true flag. When set, Rclone enforces authentication before processing the request. When absent, the endpoint is publicly accessible regardless of whether --rc user or --rc pass flag were configured. The operations/fsinfo was registered without this flag. This means even a properly configured Rclone deployment, one with a username and password set, still exposes this endpoint to anyone who can reach the port. The fs parameter doesn't just accept a pre-configured remote name like my S3 bucket or something like that. Rclone supports inline backend definitions, so you can describe an entire backend configuration inside the fs string itself on the fly. For example, we can provide webdub URL http example.com with a vendor equals other, and this would create the webdub backend with those settings right there in the request without any prior configuration. This is a powerful feature for legitimate use. It becomes the attack primitive here though, because it means the attacker can fully control every parameter of the backend being instantiated, including ones that execute code. Rclone processes the inline definition and instantiates a new webdub backend object using the attacker supplied parameters. At this point, Rclone is doing exactly what it was designed to do. The problem is that no one ever audited what happens when an unauthenticated user gets to specify all the parameters. The webdub backend supports a parameter called bearer token command. Its legitimate purpose is to call an external program that returns a bearer token for authenticating to a webdub server. This is useful for OAuth OIDC workflows. When the backend instantiates, Rclone reads this parameter and prepares to execute whatever binary path was supplied. There's no validation that the command is on an allow list, no check that it is a token fetching program, no check that the request was authenticated. The attacker simply sets the bearer token command to whatever command they want, and Rclone accepts it unconditionally. And as you can see, this is where the problem arises. Rclone calls go's exec command function with the attacker's applied value. The command executes directly as the operating system user running the Rclone process. On a default Docker deployment, that's root. On a production server, it's whatever service account Rclone runs as. One HTTP request, no credentials, no prior access. Command executes. The result is full unauthenticated remote code execution. The attacker can read files, write files, download and execute further payloads, or establish a persistent reverse shell, all from a single post request to what looks like a harmless file system info endpoint. Let's look at how this vulnerability is exploited. First, we're going to create a vulnerable lab environment. We do this using Docker. Next, we need to create a payload, in this case, a simple reverse shell script. This reverse shell script is going to be pointing to the internal Docker host. We can verify this IP address by running ipadder, looking at the Docker interface. You can see that it is corresponding. Next, we need to serve this script somehow. So we use a Python server. The vulnerable endpoint is operations/fsinfo and the parameter bearer token command. We're going to be sending a simple curl command that issues the curl command to download the script from our HTTP server. Once we issue the command, we can see in the HTTP server that it did indeed receive a fetch for the script. Using the same endpoint, we send a command to make the script executable on the host. We start a listener. In this case, I will be using Penelope, but you can use Netcat or any other listener of your choosing. Once again, we send a command, and this time to execute our script. As we can see, we received a connection to our listener, and we can verify by running who am I. From NVD, we can see that the remediation for this vulnerability is to update the version of Rclone. So if we test with running another lab environment, but this time using a patched version, we're going to see that it does not work. As we can see, this time we get 403 forbidden.